Alrighty, let's go on page 64. When we are done, we are going to look at the properties of logarithms, some ways to condense and expand them so that we can use this to solve logarithmic equations. The first thing we have is the product property. So product means we do what? Multiplication. All right, so we have log base b of some base of two things being multiplied together, m times n. So we can split that or expand it into two logarithms with the same base. So log base b, whatever that was, of m plus log base b of n. So that's how we expand it. It works in both directions. So if we're adding two logs with the same base, we can take the two arguments and multiply them together. So we need to take that. We're going to go through some examples of expanding and condensing these logs. Remember, they have to have the same base. So when I look at number 1, they both have log base 3, so they have the same base. I can condense that into log base 3 of 9 times 5, which means I get log base 3 of 45. Okay, so we have condensed them like so. On number 2, I have two logs with the same base. What's the base of that log? 10. Good. So this gives me log base 6, I'm sorry, no it doesn't, log base 10 of 6 times x minus 3. So that gives me log of 6x minus 18. Okay. Any questions about that? All right, on number 3, what's the base of this log? E. Very good. So this becomes natural log of 4x squared times 3x cubed, which would give me the natural log of 12x to the 5th. Any questions at this point? So that's condensing them. Now we're going to expand them. Okay, hang on a second. Let me make sure they're all here. Arizeth, Avril, and Elizabeth. They're all here. I got it. That's yours. That's yours. Arizeth. That's yours. Okay. All right. So now we're going to expand. And we're expand using the product property. There's different ways to expand some of these logs, but it specifically says using the product property. So what are two numbers that multiply to give me 72? 9 and 8. So I can do log of 9 plus log of 8. Would you agree that that works? Is that the only answer? No. What are two other numbers? 12 and 6. So I could do the log of 12 plus the log of 6. On a question like this, you wouldn't have to give me two answers. You only have to give me one. We're just going to do two in our notes because I want you to realize that there's more than one right answer sometimes. Okay? All right, so number 5 looks like we could split it up into 9 divided by 10, but that's not the product property. That's the quotient property. So if I'm going to use the product property, I could say this is the natural log of 9 plus the natural log of what? 1 over 10. Okay? That's one right answer. Or I could do the natural log of, what do you think? What else could I do? 3. I heard 3 plus what? The natural log of 3 over 10. And there's an infinite amount of other possibilities, but you don't have to get that creative. You may need to get creative though. The whole purpose of this is if I'm solving and for some reason, for whatever it is I'm applying this to and I need, maybe I need it to get the natural log of 3 out of there somehow, then I'd want to go with this version instead of this version. It just kind of depends on what you need. Right now we're just looking at how you can do it. All right, so then if I'm supposed to use the product property, I need two things that multiply to give me this. What am I going to have to do with this? Factor. So log base 5 of, so this is a difference of squares. This is x plus 2 times x minus 2, which means I can split this up into log base 5 of x plus 2 plus log base 5 of x minus 2. Okay. Any questions at all? All good? Okay, beautiful. All right, so now let's look at the quotient property. So I have log base b of m divided by n. So when I split that into two logs with the same base, instead of adding them like I did for the product property, I'm going to subtract them. So this becomes log base b of m minus log base b of n. So we can condense and expand. We're going to start by condensing. I have two logs, same base being subtracted. I condense it into a single log with division, so 96 over 6. And what is 96 divided by 6? $16. Thank you. All right, so then again, I have two logs with the same base. This becomes the log of 8x to the 10th over 4x squared. So when I divide that, that's going to give me 2x to the what? Eight. Good. You subtract your exponents. All right, and so then this one, that's going to give me log base 7 of the square root of 40 over the square root of 5. So this is the same thing as the square root of 40 over 5. You can divide everything that's under the square roots. There's no addition or subtraction to stop me. So this just becomes the log base 7 of the square root of 8. But then I can simplify the square root of 8. What's the square root of 8? 2 square root of 2. Very good. That's my answer. Any questions? All right, so then I'm going to expand it using the quotient property. So again, I have to actually, there's an infinite amount of answers here, but I can do log base 3. What are two numbers that I can divide that will give me 8? 16 and 2. Okay, so log base 3 of 16 minus log base 3 of 2. That totally works. Absolutely nothing wrong with it. But let's come up with another one. What are another two numbers? 24 and what? 3. Log base 3 of 3. Or 64 and 8. I mean, there's, like I said, there's an infinite amount of things there. Okay. All right. So I need to expand this. I get to use the quotient property here. So this can totally just be the natural log of 3 minus the natural log of 4. But it could also be something like the natural log of 6 minus the natural log of 8, because when I put 6 over 8, it would reduce to 3/4. Okay, so we have an infinite amount of answers there as well. And number 12. I can change this into the log of x minus 7 minus the log of x plus 1. I can also put a coefficient in front of each one of those little sets of parentheses because then they would just reduce once you divided them. It'd be fine. Okay? Any questions? All right. So then we have the power property. Log base b of m to the nth power. All that happens is this exponent can come out front. So this can become n times the log base b of m. And it works the other way as well. All these work back and forth. So if I want to condense this and I have 3 times the log of 6, I can take this 3 and it can become an exponent up here, and this just becomes the log of 6 cubed. And then what is 6 cubed? $216. Very good. Okay. Got to be able to come up with those efficiently and accurately without a calculator. All right, so 1/2 here can become an exponent. So this gives me log base 4 of 81 to the 1/2 power. What's another way of saying 81 to the 1/2 power? Square root of 81. And what's the square root of 81? 9. So this is log base 4 of 9. All right, so then this x minus 1 is being multiplied out here. It can become an exponent. So this becomes the natural log of 4 to the x minus 1 power. And then there's nothing else. We could do things with that, but it's fine. All right, so then the other way the power property works is by expanding. I have log base 2 of 5 to the x power. So this x can come out front as an exponent, and this just becomes x times log base 2 of 5. On number 17, I'm supposed to expand using the power property, but I don't have an exponent. Can I rewrite that to get an exponent? Yes, I can. So this gives me the natural log of 2x plus 1 to what power? 1/3. Good. So then this becomes 1/3 times the natural log excuse me, of 2x plus 1. So same thing here. I don't have an exponent, but can I make it into 1? Do you have a question? No. So yes, this can become log base 6 of 64 to what power? What power? -1 power. Good. So that can just give me the negative log base 6 of 64. But I could also have changed this into being log base 6 of 8 to what power? -2. So then that can become -2 times log base 6 of 8, right? I also could have made 64 into 2 to some power. I mean, there's lots of options there. Again, depending on if you're trying to reduce it all the way, or if you're trying to get a specific log out of it, or, what are you trying to do with it, that kind of thing. All right, any questions? All right, flip it over. Let's fill out this little reference sheet. Oh, mine's on a different page. All right, so here we go. Here's a little reference sheet. So a base 10 logarithm is just written as log of x, right? We don't write the base. A base e logarithm is written as the natural log of x. Again, that is a lowercase l and a lowercase n. It is not a capital I. All right, so some basic properties of logs. Log base b of 1 equals, right? So if you're not sure, you say b to what power would give me 1? Oh, what power would I take b to get 1? 0. Yes, 0. And then log base b of b. So b to what power gives me b? 1. All right, so there's couple of really basic things. If you don't just remember them, just think about it like I just asked you about it. So log base 6 of 1 is what? 0. Because anything to this, the log of anything, any log of 1 is 0. That's what I'm trying to say. Because 6 to the 0 power gives me 1. Then log base 4 of 4 is going to give me what? 1. Okay. All right, so product property. This is just putting everything all together so that we can have something to refer to. This is going to equal log base b of m plus log base b of n. So when I condense this into a single log, I'm going to get log base 3 of these two multiplied together, which gives me 24x. Okay. Here, when I can expand it, I'm going to need to factor. So this equals natural log of, and then I have x minus 2 times x plus 1. So that gives me the natural log of x minus 2 plus the natural log of x plus 1. Okay. Any questions at all? All right, so then I have the quotient property. When I split it, or expand it, log base b of m minus log base b of n. So this will give me the log of 80 over 16. And what is 80 divided by 16? 5. Somebody keeps whispering the answers. 5. All right, so then I have log base 2 of x over 5. When I expand that using the quotient property, it's going to turn into subtraction. So I get log base 2 of x minus log base 2 of 5. Okay. Any questions about those? All right, good deal. So then we have the power property. Remember, that means the power comes out here. So this becomes n times log base b of m. So this gives me the natural log, because the 3 comes up here, of 9 to the 3rd. And what is 9 to the 3rd? 729. Good. All right. And then I have this 2x. This whole thing is the exponent, so it can come out here. So I get 2x times log base 7 of 3. Okay. Any questions at all? All right, change of base formula is something that we talked about on Friday, but I wanted it all in this little reference sheet. So another way to change our logs is to change the base. Okay, so if I have whatever the base is, this can become, I get a log in the numerator and a log in the denominator. The base of the log goes in the base of the fraction, so you get the log of A over the log of B. This is very different than the quotient property. Okay, so let's do this one, and then let's make sure we understand how they are totally separate. If I am changing the base, I'm going to get a log in the numerator, a log in the denominator, 5 would be in the denominator, and 138 would be in the numerator. Now, I cannot reduce 138 and 5, but even if I could, I mean, even if this is reducible, I can't reduce this fraction because these are operations. And notice here, the difference, when I made this, I took 2 logs, made it into a single log using the quotient property, and then I could actually divide them. That is totally different than this because I have a log in the numerator and denominator, right? 2 completely different things, so don't get them mixed up because that's one of the common mistakes there. All right, and then this becomes, excuse me, get a log in the numerator, a log in the denominator, 14 in the denominator, 2 in the numerator, and I want you to put that that does not equal the log of 1 over the log of 7. Okay, so what I want you to get is that you cannot reduce it like that. Like that is not the same thing. It doesn't work. Okay? What questions you got? Anything? Awesome. All right, so go ahead and get this taped in. I'm going to give you your assignment. You should have plenty of time to finish it and get it turned in.